So folks, we're picking up where we left off in the last video, and we want to look at constructing the graph of the cosine function. We want to look at understanding how this cosine function works. The cosine function has its independent variable x, and its dependent variable f of x is given by the rule cosine x. It inputs a real number from the real number line, so that means from minus infinity to infinity, and it's going to output the ratio of the adjacent side of over the hypotenuse side of a triangle constructed from a reference triangle on the unit circle corresponding to an angle of measure. Careful here, folks. The angle is measured as x, and we mentioned this in the last video. So we want to start constructing this graph, and we could start doing so. Beforehand, I had you find f of pi over 6, and that's the cosine of pi over 6, which is the square root of 3 over 2. And so this is my independent variable. This is my dependent value. And so I went ahead and plotted that. There was pi over 6 and square root of 3 over 2 for that point. And we could do other points. For example, we should do f of 0. F of 0 is equal to the cosine of 0, and the cosine of 0 is 1. Why is that? And this is what I want to revisit. If we were to graph ourselves a nice little unit circle here, if we were to go plot the angle 0 right here, there's the angle 0, and that is the ordered pair 1, 0. And as a reminder, when I want my cosine value, that should be smaller. When I want my cosine value, what I want to do is take the x-coordinate of the unit circle point. Now, I want to stress, this is very confusing, folks. This is the x-coordinate on the unit circle. This x-coordinate here corresponds to points on this circle. It does not correspond to this x here, which is the angle that we're working with. Okay? So what was our angle? Our x value, here's our function, f of x equals the cosine of x. So our x value for the function is the angle 0 radians, and we computed the cosine of 0 radians to get the number 1 to get the corresponding y value. So this x and this y are not this x and this y. Okay? Same thing over here. Our x coordinate that we plugged in the function was the angle pi over 6. On the unit circle, if we were to construct the unit circle here, and we were to go to the angle pi over 6, that's this angle right here, and that has the ordered pairs on the unit circle, square root of 3 over 2, 1/2. And I want to stress that this x and this y are not the x and y with my function, the input-output, and that is very confusing. In fact, down below here I have a warning for you. Okay. Recall that we stated that for an angle in standard position, we would write that the cosine of theta is the ratio of x over y, or x over r. That was on the unit circle. Okay. So on the unit circle, we might have an angle that we labeled as theta. So here we have this angle labeled theta, and it will have these coordinates right here that will be x, y coordinates, and then we can compute this r value here, and so the cosine of the angle theta is the ratio of x over r. These x's and y's correspond to points on the unit circle, and the angle is stated to be theta here. When we're looking at the graph of the cosine function, the angle is understood to be whatever we're plugging into the function. What are we plugging into the cosine? We're plugging into x, and that is our angle. That causes a great deal of confusion, and I completely understand about that confusion. I just say that that's a confusing fact of life that you learn to deal with as you go along. Okay? So this is where, and to help with that, I think this demonstration that I've been showing you is so important. So if we go back to that demonstration, here was that demonstration here. And I've set it up so we're in pi over 12 parts. You could put yourself in degrees if you're more comfortable working in degrees, or you'd like to see how this works with degrees. I find that it gets a little bit cluttered with that, so I'll turn the degrees off, and let's graph this for the cosine function. So again, we just said a moment ago that on the unit circle, right here, for the angle of 0, this is the ordered pair 1, 0. And so the 1 is the x-coordinate of the unit circle. But that x-coordinate is what cosine outputs, and so that becomes the output on the function right here. Okay. So let's rotate up. It gets a little confusing right there. Let's rotate to right here, the angle pi over 4. So my input in my function is the angle pi over 4. I know I'm using the letter x here, but think about it in terms of input. My input is pi over 4, and my output is the cosine of pi over 4, which is radical 2 over 2, or approximately 0.707. And so we plot that point right there. Let's go ahead and do so. We just said that the cosine of pi over 4 is the square root of 2 over 2. So let's plot that point right there. There it is. That's the ordered pair, pi over 4, comma, square root of 2 over 2. And let's get caught up here. Just a moment ago we said that the cosine of 0 is 1, and so that gives us this ordered pair right here. There's the ordered pair. When the angle was 0, the cosine of 0 was 1. And I want to emphasize that this ordered pair right here is not this ordered pair from the unit circle. All we cared about from this ordered pair was the x-coordinate, which was our output of the sine. Okay. If you're feeling a little bit confused by this, please don't worry. We've got some time to get used to it. But I'm trying to highlight that is a confusing fact. And to help you understand that better, I think this demonstration is particularly helpful. As a reminder, I think it's useful to do this roll and unroll feature to help see where we're getting our domain values from. So notice that on the unit circle, I have angles and I have ordered pairs. But my x-axis here is not the x-coordinates on my unit circle, but instead the angles from my unit circle become the x-axis. Okay. And as we take this point around, the author, it's a little bit harder to do this, so the author says, okay, at pi over 6, we know that the cosine value is the square root of 3 over 2. That corresponds to this output for the function. That's why they're putting, they're kind of first finding the x-coordinate to be the square root of 3 over 2, then transposing that onto to think of it as a height, and that becomes the height of the function right there. So maybe that kind of helps with this demonstration. If you find that part confusing, just ignore what's shown in green here, and just know that we are getting, if we go to cosine of pi over 3, what's the cosine of pi over 3? It's 1/2. So when I'm at the angle pi over 3, I need to plot the ordered pair pi over 3, comma 1/2. So please, folks, again, just as before, take a few minutes and work through this, and then we'll finish out the graph of the cosine function. So pause and just explore this demonstration a little bit. Convince yourself that it's an accurate demonstration. See how it works. Maybe work with this roll and unroll feature. Maybe adjust your angle portions, put on degrees. Make sure everything seems to make sense to you, and I'll join you in a second. Okay, so armed with that information, let's finish this out. Just a moment ago, we said that if we were to take the cosine of pi over 3, that would give us the output value of 1/2. If we were to take the cosine of pi over 2, that would give us an output value of 0. Okay? And we could plot many more points on here. Let's just go ahead and do the cosine of pi. The cosine of pi is -1. So let's just remind ourselves of this. This is when we've got the angle pi, we get the output -1. Why is that? Because f of pi is equal to the cosine of pi, which equals -1. Where did I get this -1 from? I got it from my unit circle. If I go to the angle of pi, that's this angle right here, and those are the ordered pairs, -1, comma 0. And when I want my cosine, I take the first coordinate here. The first coordinate is -1, and so that's where I got this from. So remember, my angle was pi, my independent variable was pi, my output was whatever the cosine of pi is, and I've plotted that there. The cosine of 3 pi over 2, the cosine of 3 pi over 2 is equal to 0, and you can confirm that. So we've got the ordered pair 3 pi over 2, comma 0. And the cosine of 2 pi, because of the periodic nature of this function, we're back to where we started, and so the cosine of pi is 1. So we've got the ordered pair 2 pi, comma 1. And we could keep going, and we could plot a few more of these points. Scroll down just slightly. We could plot a few more of these points, and now I'm going to take a stab at graphing this. If we were to graph this function, it would look something like this. And it continues on because we can continue taking angles and plugging them into our cosine function. Remember, the domain of the cosine function is all real numbers. I've only just sketched this for the first 3 or 4 pi. So we could also look in the opposite direction, and if we were to do so, we would have this, that the cosine of minus pi is 0. Let me try that one more time. That the cosine of minus pi over 2 is 0, and the cosine of negative pi is -1, and then this graph continues onwards for negative angles as well. So here we've sketched the graph of the cosine function. Folks, don't worry, we've got all semester to get comfortable with the graph of this cosine function. My goal for you in this pre-work is to understand where we're getting these values from, and this is where I think this demonstration is invaluable. I really wish I had had something like this when I was learning trigonometry. So play around with that a little bit, and let me know if you have any questions. Thanks for your patience, and I'll see you either in the next pre-work or in class.